Alright, ladies and gents, here we go. If you did not grab a note packet, go. If you didn't grab a note packet when you walked in, you need to do that right now. Right, we're starting Unit 2. If you want a chance to do your test today, that means we need to get through our notes. So it is a shortened period. We probably won't do every single example in the notes today just because I do want to see our test. But we're going to try and get through most of it. So, Unit 2, quadratic equations. Last unit was linear equations and functions, right? Straight lines. This unit, quadratic equations and functions. We're dealing with parabolas. How many of you remember parabolas from last year? Yeah, awesome, good. So, all these wonderful I can statements, I believe, are printed right in the front of your note packet. You need to be able to say you can do them. Well, I test it. They're not on the front of your... Oh, yeah, they are.
Yeah, they are.
Sure enough. You'll notice... Hey, guys. Thank you. It is a longer unit. We do not have a testing nailed down. But once we do, I'll let you know. It's what, 10 days or something like that? Maybe more than
11 including the test.
11 including the test. So, I mean, it's at least 2 weeks worth of stuff. So, we got at least 2 weeks for our test. Yes, Larson?
Ropes.
One question for you.
Wait.
Have we had ropes all year long?
It says ropes number 1 for semester 2.
Oh, yeah.
Oh, where?
Wait, what?
Oh, yeah, sure enough. No, we do not have ropes.
Wait, where?
That is a mistake.
Wait, I'm there.
You're what?
That wasn't okay.
Alright, so, let's get started. Let's get going right away. Today we're talking about factoring, manipulating equations to solve. All we're doing today is review. Now, it might be review pieces set into new spots, but all the stuff we're going to do today is, well, there's one thing we're going to do that's not review, but most of it's review. So what is a quadratic equation? Quadratic equation is any equation with degree 2. What that means is we have an exponent of 2, right? The highest exponent is 2. So, quadratic comes from quad, meaning square, and when it's x to the power of 2, we say it's squared. Right? So it all flows together. Quad comes from squared. So we have quadratic equations. Quadratic is very good. Squared, just talk about that. Also called an equation of degree 2. Alright? Do we all have that written down in our blanks?
Yeah.
Yep. I don't know if I have enough over here.
I think it was the whole.
Alright, so what does it mean to solve? We want to find the x values that balance the equation, right? Or that we can solve the equation. It makes it true on both sides of the equal sign. So if you look here, x squared plus 5 equals 14. Both 3 and negative 3 technically balance that equation because 3 squared is 9 plus 5 is 14. Negative 3 squared is 9 plus 5 is 14. Both those answers balance our equation. Now, in this unit, 99.9% of the time, we should have 2 answers because of that, because we're taking a square root, and it can be either positive or negative. Now, there will be that 0.1% where we only get one answer, and we'll actually see that at the end of the day today. But for most things in this unit, we should be expecting to have 2 answers when we're solving. Alright? So Aiden, how many answers should we have when we solve? 2. Thank you. So, 2 different methods. First method is getting a square term by itself and then taking the square root of both sides. So this is what we're going to do when we have just an x squared on one side, or you have something squared. Alright, so for example, we have x squared plus 5 equals 20. What we would do is we get the square term by itself by subtracting 5 and taking the square root. We would solve. Or if we have x minus 4, all squared plus 3 equals 5. Right, I have one squared term. I would subtract 3, take the square root of both sides, and solve from there. So that's our first method. Our second method, we're going to use factoring. This is going to happen when we have both an x squared and an x term. What we're going to do is we're going to get one side equal to 0, and then we're going to factor it and solve. Yeah, I can hear you. So, 2 different methods. If we have just one squared term, we're going to manipulate their equation to get that by itself. If we have x squared and x, get one side equal to 0, factor. Alright? Cool? Okay. Let's try the first one. 2x squared minus 10 equals 40. Which method are we going to use here?
Minus 40.
What's What's it?
Equal to 0.
Equal to 0. Ooh, do we have an x squared and an x?
Oh, I was just.
No. And? Add 10. We're going to manipulate it to get our squared term all by itself. So we're going to add 10. Two x squared equals 50. Divide by 2. X squared equals 25. Well, how do I solve x squared equals 25? Square root it, right? X equals positive 5 or negative 5. Yes, if you want to use positive, negative symbol, you can do that. Right? 5 squared is 25, negative 5 squared is 25. So you have to use both of those answers. Okay, the second one, x minus 3 squared equals 16. Once again, I just have one squared term. Right? X minus 3 is a squared term. So I need to get that part by itself and take the square root of it. Well, is it by itself? Yeah, right? It's already by itself here. So I'm going to take the square root of both sides. Get rid of that exponent. X minus 3 equals 4. Or x minus 3 equals negative 4. I need to set up both of those equations, right? Because if I square 4, I should get 16. If I square negative 4, I should get 16. And now I can solve both of these. Add 3 to both sides. X equals 7. Or x equals negative 1. Okay, does that make sense? Okay, so that's if we have one squared term in our problem. The last problem here in our examples, we have x squared minus 4x minus 12 equals 0. Well, I have an x squared and an x term, which means I need to get it, first of all, equal to 0 on one side, which it already is, right? The other thing you need to look for before you try and factor, and when you're trying to get it equal to 0, guys, you want to have a positive x squared. Why do you think I say that? Have any of you ever factored with a negative x squared term? No. Right? So when you're solving it, try and get everything to the same side as x squared and make it a positive x squared. It'll be a lot easier to solve with. Okay? So in this case, that's our case, positive x squared. It's equal to 0. I can go and I can factor it right away. So I'm going to try and factor this. I need something that multiplies to negative 12, adds to negative 4. Negative 6, positive 2. So x minus 6, x plus 2. Does anyone remember how we solve from here? So what equals? It is equal to 0. Set both of the parentheses equal to 0, right? X minus 6 equals 0. X plus 2 equals 0. Hey, does anyone remember what property lets us do that? Ooh, this could be a treat question. No?
Trick question.
A treat question. I think if you get it right. No. It's the zero product property, right? Anything times 0 equals 0. So if either one of these is equal to 0, that whole side's going to equal 0 because it's all multiplication. Right? So solve them both. Add 6. X equals 6. Minus 2. X equals negative 2. Alright? Any questions? Any at all? Should I keep going? Okay. So what does a solution mean? There are multiple words in this unit that we're going to use for solution. We're talking about roots, right? So you're taking the root of our equation. We're talking about zeros because technically our answers are where y equals 0. In other words, it's the x-intercepts of a graph. So if we ever just give you a graph, right? Draw a parabola on a graph. We say, what are the roots of this graph? Or what are the zeros of this graph? Or what are the solutions of this graph? They all mean the same thing. I can almost guarantee you there's going to be a problem on the test. It's going to ask you for either the roots or the zeros. And you all are going to be like, oh, ooh. And all that air stuck in my throat. But you won't, because now you know, right? Roots and zeros mean the same thing as solutions. We use the same methods we were just using to find the roots and the zeros, because it's the same thing. Alright? So if I look at this graph over here, right? There's a parabola drawn on it. when you're looking at a graph, your answers are where it connects with the x-axis, otherwise known as the x-intercepts. So if I was looking at this graph particularly, my answers would be x equals 1 and x equals 3. That's where it hits the x-axis. It's what the x values are where your graph hits the x-axis. Alright? We are going to get way more in depth on graphing later in this unit, so I don't want to spend a ton of time on it today. Alright? But let's try and solve this. Let's say we have x squared minus 1 equals 0. It says find the roots of that equation. What are you going to do? Add 1, right? Just one square term, so I'm going to get that by itself. Add 1. Is this one on your paper?
Yeah.
Okay, so make sure. Square root it. X squared, x equals 1, or x equals negative 1, right? Okay. Then the next one says, what are the zeros of the function x squared plus 6 equals 22? How would I solve this one? Subtract 6. X squared equals 16. Square root it. X equals 4. X equals negative 4. Now, it wants us to check the graph to verify our answer. I can tell you if you graph it correctly, you're going to get the same answers. I don't want to spend all that time on it today because, like I said, we're going to go more in depth on it later in the unit. We're going to actually learn how to graph. Instead of just plugging x values in and finding y values, we're going to learn how to graph them later. Okay? The important thing about the graphs is remember is our solutions or our roots or our zeros are where we cross the x-axis at our x-intercepts. Does that make sense? Do you understand that? Are we all okay if I skip the graph parts? Okay, let's keep going then. So, solutions can be three things. They can be irrational, imaginary, or rational. Right? Now we're going to dig some stuff out of our vault from first semester to do some of these. First one, irrational. What am I doing to solve? Minus 2. X squared equals 10. Take the square root. Oh no.
Shoot. I.
Come on, someone!
I.
Anybody?
2 root 5.
It's not 2 root 5, but that's the right premise we're trying to get at,
Oh,
yes.
that thing.
It's called something.
The factor tree.
Simplified.
Rational
We're so close. Simplified radical form.
Oh.
Right? Yeah, we're really close. If it is not a perfect square, do not put it in your calculator and give me a decimal. I'll throw a desk at you.
Oh.
This is your warning right now. No decimals. I want exact answers, alright? So, what's going to happen is we're going to use simplified radical form. When we do that, remember we're looking, is there any perfect square that's a factor of 10? No.
Sophomore in high school.
No. So we're just going to leave it as positive, negative, square root of 10. We'll get to a problem later today where we're going to have to do the simplified radical form. This one doesn't break down at all, so that's our final answer. Okay? I want exact answers. I don't want rounded decimals. Okay? Cool? Sweet. Second one is imaginary. Uh-oh, another thing from first semester.
This is where the I comes in, right?
This is where I comes in. Subtract 13. X squared equals negative 9. Remember, try and square root it. Can I square root a negative number? No, I get an error.
You can with an I.
You can with imaginary numbers though, right? Remember, x equals positive, negative. Well, square root of 9 times square root of negative 1 because negative 1 is the same as I squared. So, square root of 9 and square root of I squared. Well, x equals positive, negative. Square root of 9 is 3. Square root of I squared is I. Now, do you have to go into that middle step if you know what you're doing? Do you need to show that? No, if you can go right from square root of negative 9 to positive negative 3i, I'm perfectly okay with that. Alright? So we have irrational, we have imaginary, and lastly we have rational, which are the nice ones. Well, see you later. Plus 4. x squared equals 25. Square root both sides. X equals positive or negative 5. Alright, does that make sense? Are we good so far? Okay, what time are we out here? Does anyone know? 31? True. Very good. Alright, we have plenty of time. Look at that. We're cruising. So sometimes you just need to know how to manipulate equations to get it equal to 0. Right? If I have x squared and x, I want to manipulate it so I get one side equal to 0. First one, how would I do that?
Minus x squared.
Okay, you could minus x squared. That is perfectly okay. However, that gives us a negative x squared then, right? So we would have to divide everything by -1 or multiply by -1, which is perfectly fine. That is a perfectly viable answer. However, I'm going to do it the other way where I keep the x squared where it is so it stays positive. Is that okay?
I guess.
You guess? Alright, perfect. So, I am going to subtract 3x to start. X squared minus 3x equals -1. Add 1. X squared minus 3x plus 1 equals 0. Now I have it equal to 0. Like I said, if you do it the way Taylor said, if you want to subtract x squared first, then you get 0 equals negative x squared plus 3x minus 1. You just want to divide by -1 or multiply by -1. It gets you to the same spot. Right? I just like my brain keeping x squared positive the whole time. You do not have to do it like I do it. That is not a requirement. Alright? Alright, the next one. 2 times w squared minus 2w equals 5. What do you think my first step should be here? What should my first step be in the second problem to get one side equal to 0? Distribute. Multiply by 2. Good. 2w squared minus 4w equals 5. Well, once I distributed, and we can subtract 5. Now I get 2w squared minus 4w minus 5 equals 0. Awesome. And guys, once we got it equal to 0, what would you normally be doing? Factor. We'd be factoring it to solve it, right? Now, some of these actually don't factor. We're going to learn quadratic formula later on in this unit. We're going to actually get to sing a cool song. You guys are going to love it. And there's even there's a story about a guy who went to a party for the quadratic formula. You guys are going to love it. Trust me.
Totally.
Alright, next one. Z times z minus 1 equals 3. We're going to distribute, right? Not factor, we're going to distribute. Z squared minus z equals 3. And then subtract 3. Z squared minus z minus 3 equals 0. Good. Ooh, last one's a tough one.
It's fine.
Talk within your pod. Give you 15 to 20 seconds. Try and figure out what are you going to do to get rid of those fractions. Yep. Can you factor that?
We're just setting them equal to 0 though. We're not even factoring.
Okay, but if I was going to solve this, you guys figure it out back there already?
You multiply it by the reciprocal.
You guys are doing a lot of really good conversation here.
Well, I said something and Ariana said no, so we kind of stopped. Alright.
What did we come up with? Anything to get rid of those fractions. No. It's going to end up being a reciprocal of one part of it, but that's not what we're looking for. It won't always work out like that, I should say. Any suggestions? Any ideas? How do I get rid of those fractions? Not the reciprocal. We're not going to put it to the power of -1, I think. That's a good idea though, right? I would have flipped it for us. But unfortunately, that doesn't work. By just any denominator? X squared. The least common denominator. Good. Right? In this case, it is x squared. Yeah. So guys, when you come across a problem like this, if you have fractions, if you multiply all the way across by the least common denominator, remember we did that first semester. If we multiply this by the least common denominator, which in this case is x squared, all of our denominators cancel out. I get 5x squared plus x squared over x minus x squared over x squared equal to 0. Right? I just distributed x squared all these pieces. 0 times x squared is 0. Well, 5x squared plus, what's x squared over x? X. Minus, what's x squared over x squared? 1. Right? 3 over 3 is 1. 2 over 2 is 1. X squared over x squared is 1. Equal to 0. Notice, when I multiply by the least common denominator of all my denominators cancel. I'm left with no fractions, and then I can go ahead and solve them. Alright? Cool? Ish. 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 Okay. How many problems do we have here to do?
5.
Is there 5? Okay, we are going to do 3 of them, and then look at our test. Cool? Deal? Alright. We're going to do the first 2 and the last one. So, first of all, x squared equals negative 6x minus 9. Aubin, what should I be doing? First one. Should I be trying to get x squared by itself so I can square root it, or should I try and get one side equal to 0? Thanks, Aubin.
Sorry.
So I'm going to get one side equal to 0. I'm going to add 6x to both sides. X squared plus 6x equals negative 9. Add 9 to both sides. X squared plus 6x plus 9 equals 0. Awesome. Thank you, Aubin. I got x squared that's positive. I have one side equal to 0. Tui, what should I do next?
Factor.
Factor. Good. X squared plus 6x plus 9 equals 0. Factors 2. X plus 3, x plus 3. Good, right? Multiplies to 9, adds to 6. Okay. Lexi, once I factored it, I do what? Shh. What'd you say? Both of them equal to 0, right? Take x plus 3, set it equal to 0. Take x plus 3, set it equal to 0. Subtract 3. X equals negative 3. Subtract 3. X equals negative 3.
They're the same answer.
They're the same answer. This is that one time, right? What I was talking about earlier where he said there's going to be a chance we only get one solution. That's going to happen when we factor it, and it factors into 2 of the same pieces, right? So they both want the same number then. Alright? So this is one of those rare occasions where one answer is okay. You just got to put x equals negative 3. Okay? Cool? Sweet. Next one. X squared minus 5x equals 0. Factor. I like that. How do I factor it, Renee? In the back?
X. I'm not x.
Yep.
And then x minus 5.
Good. X times x minus 5 equals 0, right? It had x squared and had x in it, so I knew I had to get one side equal to 0. I did that. Started like that. Then I factored a GCF out. It won't always be like this with 2 sets of parentheses. Sometimes we're factoring just a GCF. Now, what do you think we do from here then, Ange? Set both of them just like we did before. It equals 0. X equals 0. X minus 5 equals 0. Add 5. We get x equals 5. Or x equals 0. Okay? Is that okay with everybody?
Yeah.
Okay. Our last one, we're going to skip the next 2, go to the last problem. X plus 4 squared plus 10 equals 210. Okay. Is this one of those where we have just a squared term, we want to get it by itself, or is this one where we have x squared and x, so we want to get one side equal to 0? We have just the squared terms, we want to get it by itself. Very good. So we're going to subtract 10. X plus 4 squared equals 200. Well, once I have that squared term by itself, I'm going to take the square root of it. X plus 4 equals, square root of 200, a nice number? No. So I need to look and see. Square root of 200. What's the biggest perfect square that goes into there? 100. So I'm going to break down square root of 100, square root of 2, right? 100 times 2 gets me 200. Square root of 100 is 10. Square root of 2 is not a nice number, so it stays the square root of 2. So when I go to set this equal, I get x plus 4 equals 10 root 2. And I get x plus 4 equals negative 10 root 2. Right? Whenever I take the square root, I need both the positive and the negative answer. So when I go to solve it, minus 4, x equals negative 4 plus 10 square root of 2 minus 4. X equals negative 4 minus 10 times the square root of 2. And those are my two answers. If you want to write it as negative 4 plus or minus 10 square root of 2, that's fine as well. Or you can separate it. And what are you going to ask?
Can't we subtract / add 4 to 10?
Can someone tell me why we cannot do that?
Because it's like multiplying, so.
Exactly, right? Just like order of operation. We have multiplication here at 10 times the square root of 2. So that would have to happen before we could add. So we can't do that addition subtraction unless we had that multiplication done already. Yes, ma'am?
Do you have to put the 4 in front of it?
You could put 10 root 2 minus 4 or negative 10 root 2 minus 4. That would work as well. I just don't put it in front. I don't just how my brain works. So no, you do not have to. Sweet. Any other questions? Awesome. Swipe up. Subscribe.